Hello everyone and welcome to my presentation on molarity by Zoe. So these are the table of contents. So the first slide that we are going to be learning about is called molarity. And the definition of molarity is that it is a concentration of a solution, and it is the number of moles of solute per liter of solution, and its unit is written as a capital M, which is meant as molarity, while the unit conversion that is used is concentration, which is written as a C, equals to N over V, N being the amount of moles and V being the amount of volumes. And when a molecule is in brackets, like for example over here, we have NaCl, sodium chloride, in brackets, and it is defined as concentration. So when it is used in a question, it is usually asking for the molarity or concentration of a substance. Here we have an example of molarity, and it says there is 0.075 molarity in 1.2 liters of NaCl that contains 0.09 moles. And the reason to this is, let me get my pen. The reason to this is that since the equation is concentration equals N over V, number of molecules over volume, in liters, this is in liters, we would divide 0.09, which is the number of moles, so mole, over 1.12 liters, which would give us the C in this here, and it would give us 0.075 if you type it in a calculator. And the next slide is more examples on molarity so that we can learn clearly the concept of molarity. Here we have what is MgS when 35.0 grams of MgS is dissolved into a solution to create 350.0 millimeters in total. So what we have to do here is we have to figure out the concentration. Once again, since this is in brackets and it is asking for, it says what, we are going to find out the molarity, the C in the C equals NV unit conversion. So what we do here is basically what we have here is we have to find out the C, and we have the amount of volume, but we don't have the amount of moles. So what we have to do here is we have to figure out, we have to do some unit conversion. So what we have is the amount of grams of MgS, and we will also figure out the moles per grams per mole if we know the mass of MgS. So if we look at periodic table, magnesium is shown as 24.3 grams, while sulfur is shown as 32.1 grams. So we would first off add 32.1 plus 24.3, which would give us answer of 56.4 grams per mole. And now since we now have the grams per mole and we have the grams, all we need to do is some unit conversions to figure out the amount of moles. So it's 1 mole. So what we have to do here is we would have to divide. No, what we have to do here is, I am so sorry. What we have to do here is, since we have our unit conversion, I'm sorry in advance if you hear my sister playing piano. I'm sorry. So basically so now what we write is we have 35.0 grams over 1, and then times 1 mole over 56.4 grams. This way we can cancel out so what we have here is that we can cancel out the G, and the result would be whatever number in moles. So if we punch it in a calculator, we can find out that this would equal 0.62 moles. So what we do from here on is we take this, and since this is the N in the equation over here, we will be putting this over on the top, so we could put 0.62 moles over. And now here we can see that this is units in millimeters, but what we want is liters. So what we do over here on the side is we do some more unit conversions. So 350.0 milliliters times, see what 1 liter is, 1,000 milliliters. So basically we would end up with 0.3500 liters. So now we will have to plug those numbers in. No, focus. And what we would get in this case is 1.77, and I am going to round up to 3 sig figs because this is our smallest unit and it has 3 sig figs. So it would be 1.771. So this would be our final answer for number 1. And then the second one, it's a similar question, so we'll just get over it a little faster. Is since once again we will be writing our equation down because it is better to not forget every time. So C equals N over V. Basically, N in this case, we have to figure out the mass of this. And basically, we have the C and we have the V, but we don't have the N. And we need the N in order to solve for the mass over here. So what we're going to do is we're going to start plugging in some numbers. We know that C over here is 0.500 molarity, and then it will equal to N over 5.0 liters. And now what we do over here is we times both by 5.0 liters to cancel the 5.0 liters. Basically what we're trying to do here is we are trying to isolate the N over here so that we could get our answer. And so basically we will be doing 5.0 liters times 0.500 molarity. So it would result in 2.5 moles. So from here on, now that we have our moles, we can use the grams per mole unit conversion to figure out what the mass, the grams, is in this equation. So basically, one sodium is 23, but since there are 2, we're going to times that by 2, put these in brackets just in case, and then oxygen is 16.0. So if we plug this in a calculator, we will be getting our answer as 62.0 grams per mole. But over here, we know that there are 2.5 moles. So what we're going to do now is we're going to start inputting these numbers. It says 1 mole. So in order to get rid of the moles, we are going to have to times this by 2.5 mole. We're going to cancel the mole out in the equation, and then we'll be getting, basically what we do is 62 times 2.5, and then we will be getting 155 grams. So basically the smallest of sig figs we have is 5.0, so these are 2 sig figs. So what we want to do is round this up to 2 sig figs, which will just be 1.6 grams. Since we're using the number 5 rule, since this isn't a 5 and this is a 5, the closest even number would be a 6, so the number would be going up. And this is 2 sig figs, so this will be our final answer here. Okay, so onto our next slide, we have concentrated versus diluted. So basically what we have here is a concentrated substance or solution is in high concentration and more solute is added to increase the concentration of the substance, while a diluted substance has low concentration and more solvent is added to decrease the concentration of the substance. So we can see that these are the solutes and this is the solvent. Since there are a lot more solvents compared to solutes, this is a diluted substance, while in this one there are a lot more solute compared to this one. This is a more concentrated solution. So, why do we want a concentrated solution? So, there are some reasons as to why, and one of the reasons is to make certain compounds become active. And some compounds do not become active unless they are concentrated to a point. And also, another reason is that we want the full potency of the solvent. So, we want to see the solvent, how the solvent is reacting or acting when it has the most amount of solute. And the last one is we use it to discover the maximum amount of solute that the solvent can contain. So our next slide will then be on why do we dilute substances. So there are three main reasons as to why we dilute substances, and one is to make the solution safer to us. So basically, sometimes when there are too many solutes in a solvent, it can become kind of toxic to us, and we dilute it with like water, maybe bring down the amount of solute. And another reason why is so that there are more substances when it's diluted, so it makes it cheaper. And lastly, when we dilute solutions when high concentration is not needed, so it's not necessary, we don't really need it, so we just dilute the solutions. So now, an example of undiluted solutions is if 300.00 milliliters of 1.2 molarity sodium fluoride is added to 500.0 milliliters of water. What is the molarity of sodium fluoride of the new solution created? So what we know is that water is H2O. And I don't know, I just need to state that out, but so basically what we're going to do is that the formula would now equal to C1 V1 equals to C2 V2. And basically what this means is that the amount of concentration in before anything was tampered or anything was changed times the amount of volume is the same as the amount of the second molarity, the second concentration, times the amount of the total volume of the substance. So basically, if we start plugging in numbers, it will appear that C1 is equal to 1.2 molarity, because this was the concentration of the sodium fluoride before anything was added, and the volume of it is 300 milliliters as it is stated. So 300.00 milliliters, so that will be the first volume, and this is going to be the second concentration. And then the second one is the second concentration, and we want to actually this is the concentration that we want to find out for a question, because it asks what is the molarity of sodium fluoride. So we are going to leave this as it is, C2, and then we're going to put in brackets because we know the total volume of the total solution. So basically what we're going to do is we're going to add 300 milliliters and 500 milliliters, because this will be the total amount of volume that is in the solution. So what this is okay, so basically I don't want to take up too much space, so these two added together equals to 800 milliliters. And what we want to do here is going to divide both sides by 800 milliliters, and here's why. We want to leave out the unknown variable by itself, right? So we have to single it out, and since it has this 800 milliliters, we gotta cancel it out. So what we're gonna do now is basically just this formula. So basically what we do is 1.2 times 300 milliliters, which gives us 360, and then we divide that 360 by 800, which gives us a total of 0. Since the smallest here is 2 sig figs, so this is just perfect, 0.25. Never forget the unit. And then the second example is what concentration of magnesium chloride is used when 1.2 liters of the original solution is diluted to create 2.5 liters of 0.250 molarity of magnesium chloride. So it is asking us what is the concentration, the first molarity. So once again, we will be writing down our formula that we will be using. So C1 times V1 equals C2 times V2. And now what we're solving for is the first concentration. So now we have the volume of the original solution. It's 1.2 liters. And then equals to 0.250 molarity brackets times 2.5 liters, because that is total volume. And what we do here now is that we divide both sides by 1.2 liters. This is once again so as to single out the unknown variable. So what we would do here is we would cancel these out, and now we would just solve for the solution. So basically what's happening is we first times 0.250 by 2.5, which gives us 0.625, and then we divide that by 1.2, which gives us 0.5208333. But since this is also to 2 sig figs, we will be instead rounding this up to 0.52 molarity, which will be our final answer. Now, the next slide is about mixing solutions. And we mixed, this is about mixing the same solutions together, but when solutions with, wait for it, drum rolls, solutions with different concentrations result in us diluting each of these solutions individually. So the result of the concentrations will be the two original solutions' final concentrations added up. So we have an example over here, and we have a lot of space to work on. So basically what we're going to do is we're going to try solving for the two missing compounds. So there's two missing unknown variables. So the question is, when 0.20 liters of 0.500 molarity of sodium chloride is mixed with 1.200 liters of 0.24 molarity of sodium chloride, which is the resulting concentration of molarity of sodium chloride in the mixture? So I'm going to write to make it easy, I'm going to write the first solution as S1. So this is going to be oops, I did not mean to do that. I realized I was going to instead highlight. So this is going to be the first solution, while this is going to be the second solution. So to solve the first solution, we're going to have to do the concentration volume equals second oops, I'm really sorry, I don't know why that's happening right now, but please just ignore it. So the first concentration is shown here, which is 0.500 meters, I'm so sorry, I meant molarity, I am so sorry, times 0.2 liters equals, now we don't know the second concentration, but we do know the volume of the total solution, because if we add this, oops, I'm so sorry, I guess I can't do that, but, oh, I didn't mean to do that. So what I'm just going to, I don't think I need to necessarily highlight any of these anymore. So let me just rewrite the things that I just wrote. So I'm very sorry for the sound bites out. I don't know what's happening. I think the neighbor's mowing the lawn. I'm guessing the neighbor never mows the lawn, but when I'm making videos, I guess now's the time he shines. So 0.500 meters molarity brackets times 0.20 liters equals C2, which is unknown variable, times 1.400 liters. And this is because the total solution is this plus this. So basically that would result in 1.4 liters. And now what we do is we divide, once again, I was not supposed to do that. Okay, just need a straighter line. It's not straighter. Okay, so we divide both sides by 1.400 liters, and this is as to cancel it out so that the unknown variable is kept alone. So we will just cancel these out, and if we solve this equation over here, 0.500 times 0.20 gives us 0.1, and then if we divide this by 1.400, it gives us something like approximately 0.071. So this is our first molarity. This is for our S1, and then our S2 over here, we will have to once again plug in our I'm sorry. We are gonna have to once again plug in our numbers, and the first concentration is given to us. It's 0.24 molarity. See, I got it right this time. And which is times 1.200 liters. And then equals, we don't know C2, but we do know volume, the second, and it is once again 1.400 liters. And then we are going to divide both sides by 1.400 liters once again to, what is it? Cancel it out and leave the sad unknown variable alone. So if we type this in our calculator, it's 0.24 times 1.2, which gives us 0.288. And then that divided by 1.400 gives us approximately 0.206 molarity. And now our final step is we have to add these two together. So 0.071 molarity plus 0.206 molarity equals 2, drum rolls please. I can't because I'm typing this in my calculator, but if you want, you can. Okay, so our final answer will be 0.28 molarity because the smallest suffix is 2. It's 2 here and it's 2 here. So this is going to be our final answer, everyone. I mean, yeah, this is going to be our final answer. Yay. And then my next slide is going to be about, it's going to be about personal experience. And this is just, I'm just going to kind of talk about it. But when I was in grade 7 and I was still like living back in Vietnam, we had a lab day once and my class was like divided into 2 teams. And one team had to like keep on adding solvent into the solute, is what the teacher said, until it reached like its maximum, so that when you added more solute, like it would just appear, like we could see it instead of it like dissolving. While the other team had to keep on adding water onto the solvent until the like color drastically changed. It was a really fun experiment for me at the time because it was the first time I was actually like in a lab, and I didn't have much lab experiences back then, but it was really fun for me. And I think that was like well, no, I actually fell in love with science back in grade 3, but I guess this was when I started opening my eyes towards chemistry, which is really fun in one way. And the concentration team had to add sugar into the water until we could like see the sugar stuff, while and then salt into another beaker of water. I think I can vaguely remember. I mean, I think I used that term wrong. I can barely remember. While one of the incidents was that there was this boy who was like this really goofy kid. Like he touched the salt for some reason. Like the teacher specifically told us not to touch the salt. Like just hold it through the container. No, it's like a smaller than a container, like the dish that he gave us, and to pour it in so that as to not make any accidents. But the kid touched the salt and then forgot about it, and then I guess he like felt like itchy. He's like wiped his forehead or something, but then he like accidentally like the salt touched his eyes, and he was like screaming, and it was really loud and chaotic. I think that's one of the reasons why I still remember this experiment to this day. But it was really fun overall. We were just like laughing at him because we were in middle school and we're like kind of immature. But our last page is the sources, and I have a total of 10 sources, I'm assuming, and some of these are YouTube videos and some of these are pages. And that brings us to the end of my voiceover video, whatever you want to call it. And thank you for listening for a very long time. Have a good day. Thank you.